Hey everyone, Kane here from Agile Analytics. The December Power BI update dropped not too long ago, and the big news that everyone's talking about is DAX Window Functions. So in this video, I want to show you what these new window functions are, how they work, and I've got a bunch of practical examples that we can run through that should make you understand them better and hopefully help you to use them in your own projects. I'll share my screen. So we have three new functions. These are offset, index, and window. So what do? They basically allow you to retrieve a row in the table that you're working in. I'm going to talk about them in terms of a table, but obviously they work in any type of visual, but it's easiest to visualize them as working on the table that kind of sits underneath a visual. So offset retrieves a row that's offset a certain number of rows from the current row where your expression's being evaluated. Index retrieves a row at an absolute position from the start or end of a partition. And we'll get into what a partition is in a minute. So don't worry if this doesn't completely make sense. We'll get there. Window lets you grab a whole group of rows, and the start or end of the range that you grab can be either an absolute position within a partition or a relative position from the current row. Before I move on, I want to mention Jeffrey Wang's blog post. So he's got an amazing, he's one of the creators of DAX, and he's got an amazing blog post on these that delves right into all the details. So definitely check that out if you want to get right into the nitty-gritty. There'll be a link in the comments. A lot of this material that I'm talking about here has come from his blog post. Yep, so definitely check it out. So all these three functions, they have similar parameters that you can feed into them, or they kind of all work in a similar way. So these are the different parameters, and we're gonna work through. This is the order that you would enter them in, but we're going to go through them in a different order so that it makes a bit more logical sense. So the first thing that you want to define, I think, when you're approaching these is the table. So this is the table to use in the calculation, and it's the table that you start with that then becomes partitioned and sorted depending on your other parameters. So we start with a table. Let's say for this example that we're going to summarize our sales table by customer and date. So we get rows of customers and rows of dates. Normally in a report you would use all selected, but we'll have a look at that in the example. So we have customers and dates. The partition by is the columns that are used to create partitions of the table that you've specified in the table parameter. So these could be, in this case, customer, in which case each individual customer would become a separate partition and treated as like its own distinct table. So whatever operation we perform, whatever rows we retrieve gets done for each individual partition. So we specify a column that we want to partition the table by. We then have the order by column, which sorts all the partitions. So in this case where we have customer and date, one customer would become one partition, and then that customer would get sorted by date. Or the rows get sorted by date, sorry. So you would have, you would just have customer, but you would have dates going from low dates to, or early dates to later dates. The blanks one we can forget about for now. That's a reserved parameter that's not really used at the moment. It has to be kept as keep for now if you do use it. So we have our table, we partition it, and then we sort the partitions. Then within each partition, we select rows that we want to retrieve. So there's one argument for index and offset, and there's up to four for window. So an index, we can specify an absolute position within the partition. So it might be a certain number of rows from the start or end of the partition. Offset is relative to the current row, so we can specify a certain number of rows before or after the current row being evaluated. And window has both options. You can use both relative and absolute row positions to define a range of rows that you want to return. So there's this great diagram from Jeffrey's blog, which helps explain it very clearly. In this case, we've got a partition by customer and sorted by ordered by date. So just like we were saying in our previous examples. So this represents one partition, but obviously when you execute these, they would work across multiple partitions. So each customer would become a partition. But this is one partition for one customer, ordered by date. And you can see index, it's quite simple. Index 1 gives us the first row of the partition. Index 2 gives us the second row of the partition. Index -1 gives us the end of the partition, and -2 gives us the second last row of the partition. Offset works in a very similar way, but it's just relative to the current row. So if our measures being evaluated for this row here, and we write -2 in the offset row selection, then the row that gets retrieved is 2 rows previous. If we write +2, it jumps forward 2 rows. 1 jumps forward 1 row. So that's how that works. Window lets you do absolute and relative. So you can see in window you specify a start of the range and whether it's absolute or relative, then an end of the range and whether it's absolute or relative. So 1 and 2 absolute, just like index gives you the first and second rows. -1 and 2 relative gives you 1 back with the -1 from the current row and 2 forwards. So you'll get this window of rows. And then if you combine them, you can get different types of selections as well. So 4 relative means jump forward 4 rows from the current row being evaluated, and -1 absolute is the end of the partition. Anyway, enough with all the theory. Let's have a look at the practical examples. So the first example I've got for you is counting consecutive events. There's actually 2 ways to solve this, but I think the method with window is better. So the business problem that this addresses is we have a very simple data model with a fact table that contains months, and that's it, pretty much just months. And then we can describe the fact table with a RAG status, a month, and a KPI. So sorry, the fact table has keys for month, RAG status, and KPI. In a way, it's just a factless fact table. So there's no nothing aggregatable in it. We just count rows. So factless fact table with RAG status, month, and KPI. And what we want to do is we want to count the number of months that the RAG status stays the same for. So we want to count how long it stays amber, and then we want to count each row that stays green, and when it changes, we want to start the count again. But additionally, we want it to respect the KPI here where it says either hires or sales. There's 2 KPIs here. So you'll see, even though it's amber, we want to count where it's hires, but then sales starts a different count, and then hires. So we respect the filter on KPI. So the first way you can solve it is with rank X. You can see I've got the same solution in both columns, or the same result. The first way to solve it's using rank X. We basically we summarize our we summarize our fact table by month, RAG status, and KPI, and we do it for all selected of the fact table. What that means is for each one of these rows, we're returning the full table for that row. So we're grabbing the table within all the filters in the report, but not ignoring any filters within the visual. So for each row, we return kind of like the whole table within the visual. And then what we do is we rank that table, and we basically rank it based on the month. So we rank the table based on the month. So it's quite a simple solution. It works. But in my tests, the solution using window was a lot faster. It was up to, I think, twice as fast when I tested it out. And I think that's because in this solution, obviously it would depend on many factors and how many items you're ranking and the size of your model and all of those different things. But I think it's a good solution with Window. And I think the reason why is because RankX is an iterator and it's iterating our table and performing a calculation on each row. And that's not what happens in the Window solution. So the Window solution's very similar. Again, we summarize our fact table by month, RAG, status, and KPI. So for each row, we're getting all the selected, the full selected table. And then what we do in the window is we partition it by RAG, status, and KPI. We use this table that we've created. We order it by month, and then we create a window. So we can use this table as our reference because this is basically what gets returned in this relation in this summarized table here. So we've got 1 absolute and 0 relative. So the start of the partition is 1 absolute, end of partition is 0 relative. So what it does is 1 absolute is always going to return the start of the partition. And remember, we're partitioning by RAG, status, and KPI. So our first partition, if we're looking at here, would be amber and hires, just these first 2 rows. And by using 1 absolute, we get the first row of the partition, and 0 relative gives us the current row being evaluated. So if we were evaluating on the second row, the range we get is these 2 rows, the first row of the partition and the current row being evaluated. If I sort in a different way and add in sorting by the KPI, you can see it's a bit easier to understand. So we have all these ambers for hires here would form 1 partition. So if we go to any row, we're basically getting a range, a window that takes us from the first row of the partition to the current row being evaluated. And then what happens in the calculation is the last step, we just count the rows of the window that we've created. And that's why I think this solution's faster, is there's no iteration. We're just preparing a window and then counting how many rows are there rather than performing a rank row by row on a table. So if our window goes from the start of the partition and we're currently evaluating on the 4th row, the number of rows in the partition are 4, and we count the rows and get 4. So I think it's a useful way to solve some of these problems, to be able to count consecutive events across different categories. But let's jump into another example. So this one's using some HR data. It's a common scenario of looking at how a headcount is growing over time. So headcount is obviously kind of like a snapshot of how many people are in an organisation at any given point of time. And in this case, snapshot's happening monthly. Every month, the headcount gets updated to a new number. And so we can't really, it's not something we can just aggregate, because that sort of gives us a running total if we aggregate it. But what we want to do here is we want to check how much it's grown since the start of the year. We use January as a starting point, and then for each month we calculate the growth in the headcount on January. So I've used the index function for this one. And this is how I've solved it. So we have a current value variable here, and that just returns the headcount for each month. So in April, it gives us a headcount, May gives us a headcount. At each point in the chart, we get our headcount. And then in this starting value variable, I've created a calculation that always returns the first month in the year. So essentially, we use the index. We have a table that is all our selected years and months, and then we partition it by year. So essentially, just a column of months and years, and we're always partitioning by the current year. So when I use 1 as the index, it always gives us the first row of the partition. So in this case, it's always going to give us the first month of the year. So it's just a handy way to return the first month of the year. And then we can simply calculate the head count. And I use this index row as a filter in Calculate. So we calculate the head count and we apply a filter, forcing it to be overriding the filter context in the visual and forcing the head count to be calculated from the first row. And we need to add in a remove filters on date to make sure that we return this head count for the first row for all dates. So even though we're forcing the calculation to override the filter context and be the first row, we still need to use this remove filters on date. And then essentially we just write a little condition to say we only want to calculate this where we need to. So if there's no head count, there's no point calculating it. So don't do anything. Only start the calculation if the head count's not blank. And then we just calculate a change percentage using the current value, so the normal head count, and then our head count from the first month of each year that we've calculated in our starting value. And we do our change percentage calculation. And so you can see the result, we get a nice trend showing us the growth in the head count throughout the year. You can see the values here where it goes up. The percentage versus January keeps creeping up. And if I add another year in, you'll see that it always references the first month of the year, no matter what, and starts from January, and then for each month shows headcount growth versus January. The next example is this one. So the first one I want to look at is using window again. And what it is well, the use case, the business problem is, say you want to compare a current order or a current transaction against previous transactions to see if transactions are going up or going down or improving, but perhaps we don't want to compare to just one transaction. We want to compare to a number of previous transactions or a number of orders in the past, because as you know, orders go up and down. So perhaps comparing the current order to an average of past orders is, more beneficial than just comparing to one previous order. What I like about this solution is that I paired it with a numeric parameter. I think they used to be called what-if parameters, but now they're called numeric parameters, I think. Yeah, numeric range parameter. And I think that's kind of a cool thing to do with these window functions, or there's interesting things you can do where you can give business users the ability to adjust the rows that they're selecting in windows dynamically within calculations. Yeah, it's quite interesting. So I've used this parameter here, which gives users the ability to choose how many previous orders or transactions they want to compare against, in case, they know their customers and they know what they want there. If they want to compare to a large number of previous transactions because the customer looks like their orders are all over the place, or they order infrequently, or they want to, compare to a smaller amount of transactions, so they can choose using this slider. There's two calculations, the average of the previous transactions and then the growth on the transaction. So for the average of the previous transactions, I just remembered I need to add this in here. So for the average of previous transactions, we take the selection from the slicer. So that's just, this measure here is just the selected value of the slicer. It's the default measure that gets created when you create a numeric range parameter. And I've added +1 to that. And then I've created a window. And so for the window, again, we're using this similar pattern that we've used before. We have all selected sales by date and country region. So we're replicating the table that we can see here, but we're returning it. All selected means we're returning the whole table for each row within all the filters in the report, but ignoring the filters in the visual. We're ordering it by date, as it is here. And we're partitioning it by country region. Sorry, I'll zoom that in. Partitioning it by country region. So each of our countries is a separate partition. very similar to what you see here. So for the window, we're taking the negative of the parameter value. So if somebody selects 2 in the slicer, we take -2, but we're adding 1 to it, so it becomes -3. So if we have 2 selected in the slicer, this is -3 relative to the current row. And then we have -1 relative to the current row. And so what this gives us is the row before the current order, and then 3 rows back from the current row being evaluated, sorry. And so, because we don't want to include the current row in our average, so we want to take the 2 rows previous. So we go 1 back from the current row and then 3 back from the current row. And then I've put here in this variable a count of the window, so we know how many rows we're returning. So, you know, if there's 2 selected in the slicer, it means we're returning 2 rows. I'll put these back in because it might be useful. This would be 2. And then we have a little condition here that says if the amount of rows in the window is less than the parameter value, then blank. So why would we do this? This is in case there is not enough previous rows to do the average. So we say we want the previous 2 rows for our average, but for whatever reason, there's, you know, we're only in the 2nd row of the partition, so there isn't previous rows. We don't want to still do an average just on one order. We only want to return the average if there's enough rows to do it. So that's what this partition does. And then this is what this expression does. And then if that's all good, if we have enough rows to compute our average, so we have 2 previous rows, then we just iterate the window that we've created and average the sales amount for each row of the window. So again, if we have 2 selected in the slicer, means we get -3 for our parameter value and -1 for our start of the petition. Sorry, the end of a petition. Whichever way you want to do it, it doesn't really matter. It's whether it's the start or the end. We get the row before the current row being evaluated, and then 2 rows back from that, or 3 rows back from that to give us the 2 prior rows. And then we just average that and get the sales amount. And so you can see, we scroll down a bit here. When we're evaluating here, we're getting the average of these 2 values here. We're evaluating here, we get the average of these 2 values. And then from then on, if we increase the number of rows we want to see to 4, now we're getting the average of the previous 4 values. So whenever we have this number, it's averaging 4 previous rows. So then it's very simple to get the growth. We just we can just do a normal growth percentage calculation. We just put in a condition to say that if this value here is blank, we don't want to compute the change. We only want to compute it when there's a value here, and then we just do a normal percentage growth calculation, which is the sales amount here minus this one divided by this one. So yeah, there's lots of applications there that you can take from that. We can do, you know, running totals across petitions and things like that, and give, you know, users with parameters, you can give them the ability to adjust the windows where running totals are computed, or adjust the windows where averages are computed. So yeah, pretty cool. So this example is about identifying potential in customers. It's just a fictitious kind of scenario, but the idea is that we want to identify customers who've placed a high quantity order, their previous order, but we want to also throw in other conditions. So we want to say, was their last order high quantity? sometimes if a customer places a high quantity order, the next order is going to be a lower order though, because because they've ordered up big and then now they don't need as much. But we want to identify customers who might be on the up and have placed a big order and then have placed another big order. So we want to identify customers who've ordered a high quantity order and then have reordered, and the reorder has a high value to it. And then we want to flag those as being good potential. So for this one, I've used offset. And what I've done is I've created our relation table parameter, which is sales summarized, all selected sales summarized by date, country, and quantity. So basically what you see here. And then what I've done is just offset by 1 within each, the date by 1 within each country region. So just grabbing the previous row in the table by date. And then what we can do is calculate the quantity, and we can filter it by that previous row. So give us the quantity for the previous row. But we've added in an extra condition here to say, give it to me where the sales quantity is greater than 3 only. So now we're grabbing the previous, the quantity of the previous row, and we're saying only where it is large. So only return the previous row if the quantity is 4 or higher. And then I probably don't need this condition here. I could have just said if the result is not blank, but anyway, we've said if the result is greater than or equal to 4. So if it's a large quantity order, the previous row, and you could probably actually just remove this part or change this part. But anyway, if the quantity of the previous order is large, but also the sales amount is large, so our previous order was high quantity and this order has a large sales amount, then we flag it as a yes, and that's identifying our good potential customers. But I think you could just get rid of this, to be honest. Let's see. Yeah, makes it a bit simpler. Cool, so let's keep going. The next one, I actually stole this concept, or not the concept, but the idea of using window functions for this I saw in an article, a blog post by Agile Anlytic, or Data Mozart, he goes by. He's got tons of good content, so check him out if you haven't. He's got a good article on window functions, but I've done a different, I've done my own implementation, a different type of thing with it. So I just couldn't go past the concept of using this. It's such a good use case for these types of parameters. So I've done it a different way, but yeah, the idea came from there. So this is calculating the average number of days between orders. We want a calculation that works across anything. So we want to be able to, as you can see here, put it by country, put it by month, or even put it by customer or something. So we should be able to put it by customer here. Yeah. So we want a calculation that works anywhere. And let's have a look how we get there. I've used offset again for this one. So I think I had a couple of offset examples, one with index and a couple with window. This one's a little bit different though to the other ones, a bit of a different approach. So rather than using that kind of all selected pattern that we've used before, in this one, I don't want to return the entire visual. What I want to do is within each of these rows in the table, I want to return all the dates that are contained within here, all the order dates that South Korea has, for example, or all the order dates that Singapore has within this row. And so what I've done here is I've created a table of just dates. So it's just the sales dates that exist within each of these points of filter context within the table. And so what I've done is I've added a column to all the sales dates within each of these. And I've used a couple of variables. The first one is to calculate the previous date to the current date being evaluated. So this one, again, it just calculates the date and it offsets by 1. I've omitted some parameters here, so you don't have to include all of the parameters within these functions. So here I've left out the partition by and the blanks. And what that does is if you leave partition by out, it just treats the entire table as one partition, which is what I want. There's only dates in there. There's nothing to partition by. So I just want all the dates to be a single partition. There's all the details in Jeffrey Wang's blog post on what you can omit and what it means if you omit different things. But in this case, what it means is we just have a single partition, which is all the dates. And we're just calculating the date that's in the previous row. And then we have the current date, which is just calculating the date of the current row. And so what's interesting here, well, not what's interesting, but I guess to make it clearer, we have add columns here. So we're actually iterating. We have row context over this relation table, over our table that we created. So we're going through row by row with add columns. So because we're calling calculate, though, within our row context, we have context transition, which is fine because we've summarized sales. So we've got a unique dates. So we don't have to worry so much about context transition. Our unique dates means that we won't run into errors in numbers. So we go row by row. We have, and then we invoke context transition. We change to a filter context, and for each row being evaluated, we have the current date, and then we calculate the previous date. And then when the previous date's not blank, we return the difference between the dates. We do that just by minusing one date from the other and then converting it to an integer. You don't need to use date diff for differences between dates. You can do it just like this. So what we end up with, you could actually drop this into a query to make it easier to visualize. So let's do that. Bear with me. I think it's worth how it looks. That's right, I need the variable, my bad. And I need the return. And I'll zoom it in a bit. And then we want to return this. So if you see what we get returned, we have our dates, our sales summarized by date here. We add our column, which is the difference. We calculate the previous date and the current date, and then we return the difference. And you can see it works. We have 7 here. It's 2 days different from 5. 9 is 2 days different from 7. 10 is 1 day different. So it all works. And then the final part of the calculation, we are just iterating our query and averaging the difference. So we're just basically iterating this table that we've created and averaging our difference column and doing it for each point of filter context, I guess. And that's how we get the result. So that's all the examples I have. I hope they were useful. Hope I didn't have anything wrong in them. If I did, please let me know. Yeah, hopefully they give you some ideas about how you can use these new window functions and how they work. Thanks everyone. Thanks for tuning in. See you later. Bye.